All right, so graphing. Okay, we need to know the transformations. We should really know our basic transformations, but there are some transformations that, like for example, the square on the inside. Well, we don't have a way to describe the square on the inside. There's no transformation of square on the inside that we learned from chapter 1. So what we have to do first is be able to express this slightly differently. And the option that we have is we can bring that out using log properties. So log properties allow us to move these pieces around a little bit to then express them in ways that are more familiar. So that too is on the outside, and we can now express that. Our change in y, or delta y, we have a vertical expansion by 2. So the inside now is very clear. Yeah, that is just a horizontal shift of left 3. Okay, so we can do our transformations just like we've normally done. With logs, there are some situations where we have these extra pieces that we have to move around using properties, and we can then express them as our regular transformation properties. So log equations, we have to be careful because we have to make sure we check for extraneous solutions. Check for extraneous solutions. Okay, so we want to check for extraneous solutions anytime we solve for log problems, or log equations. So lots of ways to get rid of logs, because we're going to have to get rid of log to solve for x. We can combine the logs. Okay, we can use definition of log. We can make one log on one side, one log on the other side, and drop the logs. This one is probably much easier to combine the logs. Okay, so I get 7 squared plus log base x of 10 equals 5. Okay, I can put this into one log by multiplying the arguments, and then I can write this as an exponential function, which then allows me to undo that power 5 to solve for x. So I get x equals the 5th root of 490. Okay, we have to check, can that root be possible? Well, what's my restrictions on my base? It can't be 0, can't be negative, can't be 1. Okay, those are neither, so that is a perfectly good solution.